At EELS, we believe that a good MRM model risk management platform should be built on the following big principle. First, auditability, which means that every event that occurs in the platform should be logged, its originator and its time of occurrence as well. Secondly, reproducibility. Any result that has been produced in the platform should be reproducible in such a way that if internal or external auditor asks for intermediary details, we can run this type of experiment. Thirdly, consistency is also an important factor. Here, we mean that any relation that is supposed to exist needs to be representable in the platform. For instance, if different instances of a model implementation exist, they should certainly share some common part of the validation recipe. Fourth, comparability, or ability for the various stakeholders from the various line of defense that enter into the model lifecycle, ability for these people to cooperate into a single place where they can share objects if necessary. Fifth, security. Despite the numerous people that will enter into the process of the model lifecycle, security should be ensured, and principles such as least privilege principle must be met. Finally, last but not least, scalability. And what we mean by scalability is scalability both in terms of number of users, for the reason previously mentioned, but also in terms of dataset size on which the model and algorithm will be trained. Indeed, nowadays, these models are calibrated on datasets which are bigger and bigger. Open source technologies such as Spark or Flink, Hadoop from the Apache project enable such scalability. As just mentioned, two of the very important requirements for a good model risk management platform are auditability and reproducibility. These two are very strongly related to versioning of the various artifacts that enter into the validation process. These artifacts or objects can be classified in three types, main types. First, data. And data can be versioned itself in two different ways, as we see it, either at the file level, and here you can use a library on top of your favorite file system, or at the record sample level as offered by UDI or Delta. The second type of artifact is the code itself, and this is a problem which is quite well known by any software developer. Technologies such as Git or Subversion allow such versioning of the code. Finally, last but not least, the metadata that defines the validation procedure must be versioned itself. And here, things are a bit more challenging. As hinted during the last question, versioning of the metadata of the validation process is key, but not so easy. One approach which we believe has and makes lots of sense is to have an architecture which is based on event and CQRS. This type of architecture relies on the fact that the golden source of information database is a list of events which is itself stored in a dedicated database. The ability to rerun some subset of these lists allows us to actually retrieve the exact state that was valid at some point in time in the past. By nature, by its own nature, this list of events offer a very strong artifact for auditability. In the same way, once you are able to actually replay part of these events, you get very close to reproducibility. Finally, any more traditional type of database based on JDBC or NoSQL can be reproduced from this list of events by projection methods.